the t-test with related samples. When we start out with the t-test, we need to know about related samples and what a related sample is. As mentioned briefly in Module 21, sometimes the number of participants is equal in both treatment groups, but the participants in one group are not independent of the participants in the other treatment group. We call this related sample study. Some statistics call related samples correlated samples or the Timbit style. Now we're going to further go into detail about what a repeated measures is and what the design is. These are two types of related sample designs. In one type, we use some participants in both treatment conditions, giving the participants first one treatment and then to the other. Did you stop it? The previous lesson, we are now learning to do the 2T sample. In finding the 2T sample, you would need M, which is your mean, M2, population 1, the population 2, and also the standard deviation of the mean 1 and mean 2. To find first, you look at which numbers to use. You know to use your mean 1, your mean 2. As far as population, you can go ahead and scratch that out. That is always 0. That will always be 0. Then for your standard deviation of mean 1, mean 2, this is the formula you will use to find this. Standard deviation squared, M1 plus standard deviation squared, M2. After finding that, you plug in all the numbers that you have. This will be your formula. And your final result will be your 2T sample. The t-test with related samples. Research has shown that the color of food can dramatically affect people's judgment of how good the food tastes. Food that has a typical color is usually related as less tasty than food that has a typical color. Let's assume that we recruit 15 subjects to take a part in a study. Participants are served award-winning mashed potatoes that are smooth, white, and lightly seasoned with salt, pepper, garlic, chives, and mild cheese. The same participants are also served mashed potatoes prepared identically, except the potatoes have been artificially color blended. Participants are asked to rate the flavor of each serving using a scale where 10 equals extremely delicious and 1 equals repulsive tasting. Because the same subjects are in both treatment conditions, the study is repeated measures designed. The data looks like this. Just by inspecting the data, it is obvious that participants found the white mashed potatoes tastier than the blue mashed potatoes. Although the computational formula does not require that we commute the two means are 8.067 and 6.200 respectively. That's a mean difference of 1.86 points. However, we will have to conduct a t-test to determine whether or not this degree of difference is statistically significant. Here are the calculations. The formula we will use to conduct the difference of the mean scores is the sum of B over N, which is 28 over 15, which is from the data, equals 1.8667. To find the P-max samples, you would do the sum of the difference of the means minus population D, all over the square root of the sum of D squared minus the sum of D squared all over N times N minus 1. And here are the results, and it equals 3.834.